Let's get some practice finding standard deviation. Okay, we did one example. Let's do one more example. Okay, and it's going to be pretty similar. We're just going to find all the deviations, square them, take the average, and then unsquare. We're really just going to be following this exactly. Okay, I think I can. No, I'm not gonna mess with technology today. So our formula, right, is that the standard deviation, the sample standard deviation, is the square root of the sum of x minus x bar, all those deviations squared, divided by n minus 1. So that's just a bunch of different steps. We're going to recreate all of those steps. Our first step is going to be finding the deviations. In order to do that, we need to find the mean. We found the mean of this. Actually, I don't know if we did. But remember, it's just going to be 3 plus 8 plus 12 plus 15 plus 18 divided by how many there are. The mean is just the average. And when we type that into a calculator, we will get some number. 3 plus 8, 12, 15, and 18. Make sure we use parentheses. There are 5 numbers. We get 11.2 as our average. So we need to find the deviations and then square them, and then add them all up, then divide, and then square root. So there's a lot of steps. We'll recreate the steps from before. And you can do that in a table. Okay? So let's find the deviations. That's going to be the data value minus the average. And then the next data value minus the average. And then the next data value minus the average. Notice the average never changes. It's always the same average. We just got to find out what all of these are. That'll be negative 8.2. That'll be negative 3.2. That'll be 0.8. That'll be 3.8. And this will be 6.8, I believe. Let's double check our answers real quick. All right, this is negative 7.2, I think. No, it's negative. All right, 3 minus 11.2. This is why you don't do numbers in your head. All right, it was negative 8.2. Great. Just checking whether you're paying attention or something. So that was the first step, find the deviations. What did we do after that? Well, now we need to square the deviations, right? We need to square each deviation. So let's find that. What is the deviation squared? We'll square each of these numbers. 8.2 squared, I'm not going to do that in my head. 67.24. Take a moment and try to square all of these and see what you get. Get some practice with your calculator because it's going to be pretty tricky. Okay, and see if you get the same answer as me. Pause the video if you need to. 3.2 squared. You will need to if you do this on your own. 10.24. 0.8 squared. 0.64. 3.8 squared. 1444. And 6.8 squared is 4624. Great. What does the formula say? Formula says find the deviations. We did that. Square them. We did that. And then it says to add them all up. Okay? So let's add them all up. Let's sum them all together. If we do that, do it like over here. 67.24 plus 10.24 plus 0.64 plus 14.44 plus 46.24. 138.8 is the sum of those squared deviations. So now we have this number up here. We're getting pretty close. Now we just need to divide by the sample size minus 1. So if we take that 138, s squared, our variance, right, is 138.8 divided by 4, because there's 5 numbers, so what's 1 less than 5? It's 4. So our variance, oh, we don't need an approximately equal sign. This will be exact. 138.8, what is that? Divided by 4. That number is 34.7. That's our variance. So now we've added up the squared deviations and divided by the degrees of freedom, n minus 1. All that's left to finish off this formula is to take that square root on the outside. And again, if you want to phrase it this way, formulate it this way, you can. If you want to mimic all the steps from the last video, you can do it that way too. So S is just going to be the square root of this, our standard deviation. And that's going to be the square root of 34.7 SQRT parenthesis is about 5.89. This says that the average distance from the mean for this data set, the average distance of the mean should be about 5.89. That kind of makes sense? Sure, it's ballpark. One of the distances was 8.2, one was 3.2, one was 0.8, one was 3.8, one was 6.8. Sure, the average being 5.89 makes sense. Remember, the further something is from the middle, the more it affects the average. There we go. That's how you find it. So let's now focus on interpreting that. And let's assume that this data set represents a number of people who visit a cafe on 5 randomly selected days. Describe the center and spread if the data is symmetric. Remember, the data being symmetric means that mean and standard deviation makes sense to use. Otherwise, we'd want to use median and IQR. Okay, so we're just going to do basically like what we did over here. The average will be the mean, and it'll differ by about the standard deviation. All right, so let's get ready to phrase it our way. So that means, on average, we expect the average, which was 11.2, about 11 people to come to this cafe. You could say plus or minus about 6 people. Or you could say this will differ by about 6 people on a given day. A lot of ways that you can phrase this. Okay. But the important thing is that the average, right, 11.2, expect about 11 people if it's 11.2. And the standard deviation, again, this has to do with X bar. And this has to do with S. Okay. And then this parentheses is just another way of explaining it. That's how we can kind of interpret standard deviation. Standard deviation is the average distance from the mean. It's on average how things vary on a day-to-day basis or case-by-case basis. So, hope you enjoyed doing these calculations. We'll be using computers for all future calculations. So you can get some practice doing it by hand if you want, or you can wait until we get to the computer section. Up to you. Good luck.